so far? Yes, ma'am. You're Megan.
Yes.
Okay.
Hi. I was just wondering if we get like a formula sheet or a note card.
No formula sheet whatsoever. So I think it's better that I review some of the formulas today that you are expected to know by heart, because they are also, the department also expect you to know the same formulas by heart for the final with no cheat sheet. So the final will have exactly the same policy attendance sheet. No calculator, no formula sheet, no cheat sheet, no nothing, but no electronic devices except what you remember. Let me remind you that you are expected to know the equation of the tangent plane. I'm not going to give them in chronological order, but I think it's a good idea to review for midterm and final. Some of the must-know formulas. One. Oh, well, I discussed this before, but I need to remind you, differential. If a function of several variables. In particular, two variables most likely are the examples we worked on a lot this semester. Number two, the definition and especially formula, main formula corresponding to directional derivative. Of f at p of coordinates x0, y0 in the direction u1, u2 equals u. Just to test you, okay, well, I believe you know the formula of the differential, but without me reminding you, what was that for two variables? I expect you to say df equals
fx dx plus fy dy.
How about, thank you, how about the directional derivative of f at p in the direction of the vector u? You will need the formula. Good, gradient. Yeah, that's the easiest way to remember it, but that's not the first thing I wanted to say. Right? How did I write it explicitly? Of course, f sub x, thank you. At x0, y0 times u1 plus derivative with respect to y at x0, y0 times u2. What do we assume about it? F c1 on a domain in plane, which means differentiable with continuous derivatives. This is what we assume through chapter 11. Number 3. I think I told you, but I'm not sure. But I think I did. Review the tangent plane formulas. How about both? Well, only one is the one I consider more relevant for us, which is z equals f of xy, will imply that at p, the point on the surface given as a graph, we have a tangent plane of formula z minus z0 equals. Who tells me? Okay, now you have to remember this. Of course, it's your midterm. Review all these things by Thursday. Very good. F sub x x0, y0 times,
X minus x0.
thank you Roberto, x minus x0 plus the same kind of thing in a different color because I like to play. How about orange? F sub y, x0, y0, y minus y0. Don't come to the midterm, better not come to the midterm and get a 0 than not knowing the formulas, right? Now, maybe you will see it on this midterm, maybe not. Maybe you see it on the final. What happens when you don't have the graph of a surface? Maybe you have an implicit equation, where we write f of coordinates x, y, z equals a constant. What is the tangent plane at P? Tangent plane in both cases should be what? Well, if you consider the first formula as a consequence of the second one, that would be simply easy because you would have to write f of xy minus z equals 0, and there you are, the same kind of formula implicit. So what do you write? Remember the surface in implicit form. Who gave you the normal to the surface at the point P? The gradient of who? Not the gradient of little f, don't confuse. The gradient of the big F, right? Okay, at P. And the tangent plane represents a what? The tangent plane represents exactly the perpendicular plane that passes through the point P and is orthogonal to the normal. So you're going to have your surface, your normal, and the tangent plane, which is perpendicular to the norm. Is this easy to remember? Maybe for your final. I want to check if you know. In any case, this list you have to post it in the bathroom or somewhere on a wall or a closet, because you need to know these things by the final. F sub x at point P times x minus x0 plus what? The same kind of thing, right? Mathematician y and z. So if you have the curiosity to want to prove the first colorful formula for the tangent plane using the red formula for the tangent plane, it would come as an immediate consequence. We've actually done that before. We even did the implicit function theorem. There are some very nice things you can do when you have a function of several variables. And in particular, for a function of two variables, things look really easy. I'm gonna erase 1, 2, 3 and continue. So I guess when I leave the room, I have to be careful not to leave the actual meter in the room, although I know that you wouldn't even try to check my papers. I did also something in this form, finding a direction in which the function increases most rapidly. I don't have to write it down, but I can remind you of the concept. So it's just a concept now, no formula to actually memorize. But I'll still say problem number 4, because that's what I set up on the actual exam. So what is the direction of highest ascent, steepest ascent?
direction we take.
Is the direction of the gradient.
Gradient.
And what is the direction of the steepest descent?
Just
The opposite of the direction of the gradient. Okay. So, direction of steepest ascent and descent is direction of for the graph z equals f of x1. This is the function left that I'm talking about. 5. The direction u that you found at the previous problem, I didn't ask if it's unique, okay? Because there's what? Of course it's unique because we unicize it. How do you say unicize it? You cannot say that by dividing with the norm in the second line, you have a u and a minus u. Yes.
So isn't the direction, the actual formula for it is the gradient of f over the normal of f?
So yeah, so the way okay, you want me to read the problem? I'm not going to read the actual function. So find the direction u in which the function f of xy blah 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 is here. It increases most rapidly. So what do you have to do? Say direction of that. That is, what is the direction of that or this? U equals blah blah f over the norm, respectively, minus u at b. Okay? 5. This direction u that you found at the previous problem could be perpendicular to a certain plane. Which of the following planes? I may give you multiple choice. Now, what do you have to do when you think direction of the way it's actually formulated is your direction is parallel to one of the following lines in planes. Which one? Let me give you an example. Okay. Z equals x squared plus y squared. P of coordinates 1, 1. So that means x0 is 1, y0 is 1, and z0 is 2. Find the direction of the gradient of f. Let me put z, well, okay. I'm abusing my notation. At P, and state which of the following lines is parallel to this direction. Okay. Lines in plane. X equals 2, B, y equals 3, C, x plus y equals 0, D. These are lines in plane, in the plane xy. X equals y, E, none of the above. So how are you going to do that quickly? Well, it's easy, right? So what do? I say gradient 2x to y at the point 1, 1. You don't have to write down everything. It's going to be the gradient of f at p will be to 2. That means u will be normalized to 2. What do you get?
Square root 2, square root 2.
Well, What would people do normally if they want to do it by the definition? Divide the vector to 2 by the square root of 8. Well, you can be a little bit smarter than that and say, it's the same as the direction 1, 1 divided by the square root of the sums of sum of the squares, right? It doesn't matter which one you take. All the collinear ones will give you the unique u. And that's exactly what Alex tried to say. Of course, he's thinking like in chess 2 or 3 moves ahead of that.
So that's the same as
And it's
2 over 4.
Yes, sir. It's the same as 2 over square root of 4 plus 4. But it's easier, right? It's sort of faster to do it. So why is that true, actually? Ryan is very right. So, no. Why is that true? Exactly because of that uniqueness that I told you about last time. You said, well, what is that? So you get 1 over square root of 2 and 1 over square root of 2 as that your u vector direction. Now, without doing a further work, this is just a simple multiple choice question. You are in front of your exam and you see lines in plane. You close your eyes and see all the, let's see my wife. You see all the lines in plane. Of all these lines, your favorite line has to have the same direction as the vector u. Is x equals 2? No, that's nonsense. Y equals 3, those are horizontal, vertical. That's the direction of the first bisector. So is this true? C?
That's for a
Nonsense.
parallel line.
D,
Yes.
right? So in plane xy, the first bisector is x equals y, and the number C is y minus x is called the second bisector. You've seen that in college algebra, high school algebra, more like. So we call this first bisector, second bisector. All right, so the answer is D. Do you have to say anything here? No. On the 2 multiple choice things you have, you see very well. Okay, I'm just kidding. I hope you didn't see anything. It was 3 feet away, okay. We have just a quick answer, and it's gonna be easy without algebra, without computational stuff. Just from the first glance, you'd be able to answer. Number 6. What is the maximum rate of increase in the same case in problem 5? Say what, Magdalena? What is the maximal rate of increase of f at p? And we all know what I'm talking about, or maybe not everybody, but this is good review. Who is giving you the maximum rate of increase? As I said last time in the review, that's actually the directional derivative in the direction of the gradient. But you are supposed to know without proving again that the directional derivative in the direction of the gradient will give you that what? Gradient of, norm of, exactly, the magnitude of this at p. So, and what is that in, what would that be in my case? Pay attention, please. Don't look at this. This is confusing you. Look at that, right? How much is that? Alrighty, 2 root 2. So, did I put this as a multiple choice? Yeah. So your multiple choice. How many multiple choices do you have? Only 2. It may see like, what's that maximal rate? 1, 0, 0 is silly. That means you have no increase. You're not moving. You're just lying there on the plane. Okay. What else? 2 root 2, 2, 7, infinity. I don't know. I'm giving some nonsensical choices, but one of them would be 2 root 2. So you would see it. It would jump in front of your eyes. Number 7. I think I'm gonna I thought about this and I said, one of you guys asked me, can you reopen any homework? And I said, nope. Why? Because once the homework closes, automatically, a few seconds later, all the answers are going to be out. Do I have other problems handy to create a makeup for that individual person who had the problem? My cat almost died this week, but she survived with treatment and hopefully she's going to live. So in situations of crisis, like an accident, a problem, illness, hospitalization, and so on, I'm sorry, I cannot reopen the homework. The homework is already out there with all the answers. When I extend homework, it's still during that interval when you cannot see the answers. So I can extend it by a day or two, but that was exceptional. So you have until the 4th. Is it the 4th? Okay. But once that closes, I cannot reopen it. However, I thought of giving you a compensation. Midterm exam contains an extra credit problem. Because once you told me that, I started feeling bad for the two people who had problems. There were two people who had very serious problems this past weekend. So in the midterm, you have that extra credit problem that is meant to catch up a little bit of, let's say, you missed a few problems from the homework, you had some bad day, whatever. So you have 10 problems plus 1. 7. You've seen that before, I told you about it. It's an easy problem. You have z equals f of xy. And I'm saying compute the volume of the body. Body? Body. That lies below the graph and above the unit is D. Fine. A. Unfortunately, 8 was disclosed because Ryan is dreaming of the problems in the midterm. But it was something like that. Very good intuition. So I would say a problem like that. Maybe a plane that is cutting the planes of coordinates forms something like a tetrahedron, find the volume, something like that kind of type. 9. Again, without giving you the exact values, you will have a function f of x and g of x, let's say positive over a certain interval. Set up the double integral, set up a double integral for the area of the domain between f and g contained. Compute, do I say compute? Yeah, compute that and also reverse the order of integration to check your work, your answer. Because here I want the precise answer, no guesses. It's gonna not be hard at all. Very nice friendly functions, very nice friendly elementary functions. I have done this before, but I'm not gonna repeat what it was. I did it in it's like the one I did last week. All right, so remember, you write the vertical strip thing, integration with respect to y first and then with respect to x. switch to the horizontal strip method. You have integration with respect to x first, and then with respect to y. Okay, and the actual algebra here will be extremely easy. Expect to be done in one line. So you will have something extremely simple. 10. It's another long exam, so I have to try to test everything you know without you spending more than 1 minute per problem just to conceive the result. Finally, oh no, now 9 I split it because I felt pity for you, so I changed my mind, I put just set up the double integral and reverse the order of the integration. So you will have to write integral equals integral, nothing else, no answer, no number. And in 10, actually compute any of the two integrals at number 9 to find the area of the domain. Just like we did last time. And you don't have a calculator, okay? Suppose your answer would be, what was last time? 1/6, I don't know. If you give me decimals, I'll be very upset. You have to give me the precise answer for that problem because it's so easy to compute that you would have no need for use of a calculator or software or any kind of electronic device. And finally, number 11. In number 11, I shouldn't say what it is because it's extra credit, but I still say what it is. It's some simple integral where you are going to have to use spherical coordinates. And shut up, Magdalena, because you're talking too much. So again, number 11 will be a triple integral that is easy to compute. And where you're gonna, well, you don't have to use spherical. You can still do it with cylindrical coordinates, for example. But it's a big pain doing the cylindrical coordinates for that kind of problem. So imagine maybe I'm hooking up the domain to be a sphere. The problems we worked as a training in class are actually harder than the ones I put on the exam. I had a professor, I was a graduate student, and he used to say, the easy problems is for the professor to work in class as examples. The hard problems are for the students to have on the exam. I think exactly the opposite. Okay, because when you are in training for any kind of sports or skill or music, you have to train yourself above the level of your competition. Otherwise in a competition you'll be very bored. So what you do in the training should always be harder, whether you are an athlete or a mathematician or a violinist or whatever. Okay? So you're not going to see something like intersect two cylinders, passing one through the other, or the cone, ice cream cone between a paraboloid and a cone and full of ice cream. Nothing like that. Something simpler. And you may guess what it is, but keep in mind that for spherical coordinates you have to know the Jacobian. Don't hesitate. That's assumed to be memorized. Don't ask me in the middle of the exam, what was the Jacobian for spherical coordinates? You're supposed to know that as being what? What was that? Roberto knows. R squared sine phi, and phi was what? A friend of yours. The latitude from Santa Claus. Measured down all the way to pi. Theta is the longitude from 0 to 2 pi. You are going to have some very nice domain. Okay? All right. That's it, guys. That's what the exam will say. And I'm asking you for a few things. First of all, you are already prepared. I guarantee. Do not stay up late that night. The biggest mistake students make is staying up the night before a midterm or a final because they wanna study everything. That's bad. The next day you will be tired, then you won't perform as well. Second of all, do not be nervous at all. You have no reason to be nervous. You have plenty of time, you have plenty of things to write down. Okay, about the way I grade. If you leave the problem completely blank, yes, that's a 0. But if you provide me with at least a hint, a formula that serves you, not just arbitrary formula that has nothing to do with it, but a formula that's in the right direction, I give you partial credit for everything. So you have no reason to freak out. Even if you mess up, let's say in 1 or 2 problems, your algebra at the end, you should still gather lots of credit. I wrote the exam especially because I myself hate some numerical answers from web work. I made the answers be fat and sassy, not like the ones in the web work, so something that you could do even mentally, not have to struggle with those. Several people asked me to go over the last 2 problems of the homework number 4. I'll give you an example of a problem that bothered a few people, and it's somewhat interesting because of course I make the algebra easier than it is. You have some 2, 3, 7, 9, I don't know. You have a function x and y that are both functions of u and v. And instead of asking you for the determinant, well, one of them may have asked you for the determinant of the functions x derivative of xy with respect to v as Jacobian, but the other one was asking you for just the opposite. Well, several people didn't see that, and they kept asking me, so I answered some 20 questions during the weekend exactly about problems like that, which doesn't bother me. I think I would have had the same problem when I was like you. The easy part on the first Jacobian is that you have 1 minus 1, whatever that is, as the definition is x sub u, x sub v, y sub u, y sub v. These are the partial derivatives, and that's called Jacobian. And what you have, you have an easy answer. In this case, you have the answer -2. And if you, however, are asked by the author of the problem, whoever created the problem of this, and you put -2, is going to say no, this is not correct. And this is what happened to several people. Now, there are 2 ways around it. There are 2 ways you can solve that.
On the book it says that the reverse, that Jacobian times the reverse Jacobian is equal to 1, so you can just do the inverse.
And I'd say that I want to say why that is, okay? For a student who doesn't know why this Jacobian is exactly J inverse, there are still chances the student can say, well, here's how smart I am. I'm going to say u out, v out in terms of x and y. I inverse the functions because they are linear functions, bifurcate linear system. So I say x plus y. This is elimination called, when we were little, this was called elimination. 2u x minus y equals 2v. So u is x plus y over 2. That means 1/2 of a x, 1/2 of a y. Right, guys? I'm right?
Mm-hmm.
Okay. And 1/2 of x and minus 1/2 of y. And then what does the student say? I know what I'm going to do. Just by the same definition, I say the u, v, the x, y, as I have an inverse function and I knew how to invert the system, I get 1/2 Not matrix, Magdalena, okay. Turn it. 1/2, 1/2. Yeah, 1/2 minus 1. And guess what I get? What do I get? Exactly what Matthew was saying. But I did it the long way. I got minus 1/4, minus 1/4, which is minus 1/2, which is
Inverse.
the inverse of that. And you're gonna ask me, okay, Magda, I don't understand why. That's why I want to tell you a story that I think is beautiful. The book doesn't start like that because the book doesn't necessarily have enough space to remind you everything you learned in Calc 1 when you are in Calc 3. But if you think of what you learned in Calc 1, in Calc 1, your professor, I'm sure that he or she showed you this. If you have a function y equals f of x, assume this is a C1 function and everything is nice, and then you have that f prime of x exists and is continuous everywhere. That's what it means C1. And you want to invert this function. You want to invert this function around a point x0. So you know that for at least for some interval that f is 1 to 1, so it's invertible. Invertible. What is the derivative of f prime ay? Somebody asked you, so what is the derivative of the inverse function as a function of x with respect to x? And you go, well, I don't know. If you a little bit remind yourself how you did that, was this hard? Anybody who remembers the formula for the inverse function?
Okay,
1 over f prime of x. Assuming that you do that at an x0, right? Assume that f prime of x0 is different from 0. Now, how would you prove that and how? Well, too much memorization. This is what we are doing in the derivative of e to the x was what? To the x. What was the derivative of natural log of x? 1 over x. Okay? Now, when you have an arbitrary function f and you compose with the inverse, what is it by definition? Of x equals x. So this is the identity function. Chain rule tells you, wait a minute. Chain rule will tell you how to prime the whole thing. So I prime, what is this animal? F of f inverse of x is the composition of functions, right? So apply chain rule to f of f inverse of x, all prime with respect to x. What is x prime with respect to x? X prime with respect to x is 1. Already. Chain rule. What does the chain rule say? Chain rule says f prime of f inverse of x times a function on the outside prime first. We go from the outside to the inside one step at a time. Derivative of the guy, you cover f with your hand. Derivative of the guy inside, the core function inside, that will simply be f inverse of x prime with respect to x, right? Equals 1. That was x prime. So, the derivative of the inverse function, alrighty, f inverse prime is 1 over f prime of f inverse of x. So if you think of this being the y, you have f inverse prime at y equals 1 over, well, yeah, if you put it at x, it's f prime of f inverse of x. Okay, because the f inverse, this is x, this is f of x, this is the y image, and when you have f inverse, x is the image of y. So f inverse has an input, if x is, how is this called, in the domain of f inverse, that means who is in the domain of f? F inverse of x. So 1 is x, 1 is y. All right? Okay. So keep that in mind, that when you have to invert a function, what do? You say 1 over the derivative of the initial. So the derivative of the inverse function is 1 over the derivative of our initial function at the corresponding point. This is how you did the derivative for the Calc 1 people. All right. So how do I apply that formula? Well, I have two functions here. One is e to the x, and one is natural log of x. How do I know they are inverse to one another? Their graphs should be symmetric with respect to the
Y equals x.
with respect to the first bisector. Assume that f of x is e to the x, right? Okay, f inverse of, well, let's say f inverse of y. That would be natural log of y, right? So what if you put here, what is f inverse? It's natural log. Let's say in a simple way to write it, simple notation. According to that formula, how would you do the math? You go f inverse prime of x must be 1 over the derivative of f with respect of f inverse x. So you go, wait a minute, okay. Who is f inverse of x? So if f of x is equal to the x, who is f inverse of x? You want me to change the letter? I can put a y here. But in any case, I want to convince you that this is 1 over x. Why? Because f prime is e to the x, right? This is going to be e to the f inverse of x, which is e to the natural log of x, which is x. That's why I have x here. So again, if f of x equals e to the x, then f inverse of x is the natural log of x. By this formula, you know that you have to compute natural log, this is as f inverse, natural log of x prime, right? What is this by that formula? 1 over the derivative of f prime computed at f inverse of x. Now, who is f inverse of x? F inverse of x is natural log of x. So again, let me write. All this guy here in the orange thing, this Mr. f inverse of x is ln x. Who is f prime? F prime of x is e to the x. So f prime, the natural log of x, will be e to the natural log of x applied to natural log of x, which is x. So you got x. All right? So remember this formula, professors actually avoid. They say, oh my God, my students will never understand this composition thing, derivative. So Magdalena, I don't care, you are the undergraduate director, I'll never give it like that. That's a mistake. They should show it to you like that. F inverse prime of x equals 1 over f prime of what? Of the inverse image of x. Because you act on x, so if x is acting on, this is f of x, then you have to invert by acting on f of x, like this and like that. If x is in the domain of f inverse, that means what? That in the domain of f you have f inverse of x as an input. So instead of giving you the formula, they just make you memorize the formulas for the inverse functions, like, believe me, you take e to the x, it's e to the x the derivative, you take natural log of x is 1 over x derivative. Don't worry about the fact that they are inverse to one another, and you can relate the derivatives of two inverse functions. They try to stay out of trouble, because this is hard to follow, right? You could see that you had to buzz your brain a little bit and concentrate. What is this woman saying? This looks hard. But it's the same process that happens in the Jacobian. So in the Jacobian of a function of two variables. Now, remember the signed area that I told you about. Signed area notion, what did we say? We say that dA is dx dy, but it's not the way they explain it in the book, because it's more like a wedge thingy. And that wedge thingy had a meaning in the sense that if you were to not take the exterior derivative dx dy, but take it dy wedge dx, it would change sign. So we thought of signed area before. When we did dx wedge dy, what did we get in terms of Jacobian? We get j, dr, d theta in polar coordinates. Do you remember who this j was?
R.
Very good, r. In the simple case of Cartesian versus polar, Cartesian going to polar, you have a function f. Coming back is called the inverse function. So I'm asking, this is the Jacobian of which function? This is the Jacobian of the function that goes from r theta to xy, right? If I want the Jacobian of the function that goes from xy into r theta, I should write, well, the r d theta will be something times dx dy. And now you understand better what's going on. 1 over j. 1 over j. So Matthew was right in the sense that he said, why are you so clumsy and go ahead and compute again uv, express uv in terms of xy, waste your time and get minus a half. What was that, guys? Minus a half. When I'm telling you that for the inverse mapping, the Jacobian you get is the inverse of the Jacobian. It's very simple. It's a very simple relationship. I could observe that. And he was right. So keep in mind that when you have Jacobian of the map from where x, y are functions of uv, this is 1 over the Jacobian where you have uv as functions of x, y. So you have inverse mapping. In advanced calculus, you may learn a little bit more about the inverse mapping theorem. This is what I'm talking about. For the inverse mapping theorem, you go, well, if the derivative of these two with respect to these two are done as j Jacobian, the derivative of these two with respect to these two in a Jacobian will give you just exactly J inverse, or 1 over J. J is a real number. So for a real number, whether I write 1 over J or J inverse is the same. Okie dokie. So, as an application, do you have to know all this? No, you don't. But as an application, let me ask you the following. Something harder than it is in the book. In the book you have simple transformations. What is the Jacobian of r theta, theta phi or phi theta? It doesn't matter. If I swap the two, I still have the same thing. If a determinant swaps 2 rows or 2 columns, do you guys know what happens? You took linear algebra. You swap 2 rows or 2 columns. It's going to pick up a minus sign. Very good. But only 3 people in this class take linear algebra. So, how shall I denote? Not J, but the notation was del. And this is J. So del r phi theta over del x y z. How do you compute that? You say, no, I'm not going to compute it by hand because until tomorrow I'm not going to finish it.
Isn't it a 3x3 matrix?
It's a determinant. So when you are to write this, you're not going to do it because it's a killer for somebody to work like that in spherical coordinates with all those inverse functions. Do you remember as a review what spherical coordinates were? X, Y, Z versus r theta phi. We reviewed that. Theta was the longitude, phi was the latitude from the North Pole. So X was, who remembers that?
R sine phi times
Cosine theta, r sine phi sine theta, and Z was the adjacent guy. Remember, this was the thingy, and this was the phi. And to express x, the phi was adjacent to it. And that's why you have cosine phi. It's a killer if somebody wants to pull out the r phi theta. First of all, r will be easy, but the other one's a little bit of a headache. And with all those trig functions, you would waste a lot of time to compute the determinant. What do? You say, well, didn't you say that if I take the inverse mapping, the Jacobian will be 1 over the original Jacobian? Yes, I just said that. So go ahead and remember what the original Jacobian was and leave us alone, you're going to say. Right? And you're right. What was that I just said the Jacobian was? You told me. I forgot it already. R squared sine phi, right? So if somebody's asking you to solve this problem, you don't need to write down anything. You say just 1 over R squared sine phi. I'm done. But I'm not going to ask you. Of course, I saw this problem exactly. Find the Jacobian of the inverse mapping for the spherical coordinates. That was given at Princeton. In advanced calculus, there were 3 variables, and then there was a generalization to n variables. But Princeton is Princeton. I'm not going to give you anything like that to compute in the exam. And I just expect that you know your basics about how to compute double, triple integrals, use the Jacobians, and be successful with it. I would say let's do one last problem about the review, although it's not in the midterm, but I'd like to see how you solve it. a student from another class, Calc 3, came to me, and I was hesitant about even helping him on the homework because we are not supposed to help our college students. So I told him, did you go to the tutoring center? And he said, yes, but they couldn't help him much. So I said, okay, so let me see the problem. He showed me the problem, and I wanted to talk about this problem with you. This is not a hard problem, okay? So we just have to see what this is about, understand what this is about. So you have the z equals x squared plus y squared, which is the paraboloid. Sorry about my typos. We didn't write this problem in the book. So I suspect that his instructor came up with this problem. This is a cone. We only look at the upper halves. Do these surfaces intersect? Draw the body between them if the case. And compute the volume of that body. And what do you think my reaction was? Oh, this is a piece of cake. And it is a piece of cake, but one should need to learn Calc 3 first in order to help other people do Calc 3 problems, especially if they are not in the book. So one has to have a very good understanding of the theory and of geometry, analytic geometry, and conics before they move on to triple integrals and so on. Can you imagine these with the eyes of your imagination? Can we draw them? Yeah. We better draw them because they are not nasty to draw. Of course, this looks like the Tower of Pisa. Okay. Let me do it better. X, Y, and Z. And then I'll take the cone. Well, let me draw the paraboloid first. Kind of, sort of. And then the cone. I hate myself when I cannot draw. If you were to cut, slice up, it would be this. And who asked me last time, was it Alex or Ryan or maybe somebody else who said maybe we could do that even in Calc 2?
Yeah.
You asked me. You take a leaf like that and you rotate it around the body like in the, using one of the two methods that you learned in Calc 2. Well, we can do that, but you see, we are in Calc 3. So I would like to write that in terms of the volume of the body faster with the knowledge I have. Do they intersect? And where do they intersect? And how do I find this out?
Equal to each other? You always use it.
Yes. I have to make them equal and solve for Z and then the rest. How do I solve for Z? Well, Z equals Z0 gives me two possibilities. One is Z equals 0 and one is Z equals 1. Because this is the same as writing Z times Z minus 1 equals 0. So where do they intersect? They intersect here at the origin and they intersect where Z equals 1. And where Z equals 1, I'm going to have what circle? The unit circle. I'll make it in red. This is x squared plus y squared equals 1 at the altitude 1, Z equals 1. This is the plane z equals 1. Okay, so how many ways to do this are there? When we were in chapter 12, we said the triple integral will give me the volume. So the volume will be triple integral of a certain body, of 1 over a certain body, dv, where the body is the body of revolution created by the motion of, what is this thing? What shall we call it? A leaf, wing, God knows what. Something. Domain D. No, domain D is usually what's on the floor. I don't know.
L for leaf.
L for leaf, wonderful, I like that. L. Okay. So I can write it up as a triple integral. How? Using, is it easy to use it in spherical coordinates? No, that's not a spherical coordinate problem, that's a cylindrical coordinate problem. Why is that? I'm gonna have to think where I live. I live above a beautiful disk, which is the shadowing plane. And that beautiful disk has exactly radius 1, so we are lucky. That's the unit disk, x squared plus y squared less than 1 and greater than 0. So when I revolve, I'm using polar coordinates, and that means I'm using cylindrical coordinates, which is practically the same thing. R will be between what and what? 0 to 1, very good. Theta, 0 to 2 pi. How about z? Z is the z from cylindrical coordinates, the one.
Square root x squared plus y squared. Oh,
So from
squared
who's
R
on the
squared.
bottom? Who's on the bottom?
0.
So the z is
Oh,
between.
wow.
Let me write it in x first and then switch to polar. Is
Yeah.
that okay?
Yeah, let's do it.
All right. So what do I write on the left-hand side? I need water.
Square root of x squared plus y squared.
Who is smaller? Who is smaller? Square root of x squared plus squared, or x squared plus y squared?
Square root of x squared.
This is smaller. Why?
Because it's
Less than 1. I mean less than 1. This is less than 1. It's between 0 and 1. Okay? So, like, I was trying to explain this to my son, but I couldn't, but he's 10. It's so hard. So I said, compare square root of 004 with 004. This is smaller, obviously. This is 0.2. He can understand. So, okay? So this is what we are doing. We are saying this is x squared plus y squared, the bottom, the round thing on the bottom. And this is going to be on the top, square root of x squared plus y squared from the cylinder, from the cone, sorry guys, the upper half. Because I only work with the upper half. Everything is above the sea level. Good. Now, let's write out the whole thing. So I have integral from, in polar coordinates, from what to what?
R squared to R.
R squared to R, 0 to 1, 0 to 2 pi. So the order of integration will be dz, dr, d theta. And what's inside here? No. R, excellent. R. Why R? Because 1 was 1, but dv is Jacobian times dr, d theta, d dz, dr, d theta, whatever. So this is gonna be the r from the change of coordinates, the Jacobian. Is this hard? Well, let's do it. Come on, this shouldn't be hard. I mean, we can even separate the power. They separate the functions, and I taught you some tricks. The first one we have to work it out. We have no other choice. So I'm gonna have the integral from 0 to 2 pi, integral from 0 to 1, and then I go what? I go integral of what you see was z. The z between r and r squared times r dr d theta. Who is going on my nerves? Not you guys. Here, there is a guy that goes on my nerves. The theta. I can get rid of him, and I say I don't need, the theta has nothing to do with the r, so I go 2 pi, which is integral from 0 to 2 pi of 1. 2 pi goes out. Now, 2 pi times integral from 0 to 1 of what? What's the simplest way to write it? R squared in the end. I mean, I do the whole thing in the end. I have r squared minus r cubed. Right, guys? Are you with me?
Divided by 2.
Yeah. So this is when I did it, but I didn't do the antiderivative. Right? Not yet. I did not apply the fundamental. Now you apply the fundamental theorem of calc from calc 1 to 2. And tell me what you get. What is this?
Divided by 2.
1/12.
1/12. Why is that? Very good. R cubed over 3 minus r to the 4 over 4. 1/3 minus 1/4, 1/12. Very good. So you have 2 pi times 1 over 12 equals pi over 6. Thank God we got it. Was it hard? Would you have spent 2 days without doing this? I think you would have done it by yourselves. Am I right? With no problem. Why is that? Because I think you worked enough problems to master the material and you are prepared. And this is not a surprise for you like it is for many students in other classes. All right? Yes, sir.
Can you do that one in spherical coordinates?
You can, but it's gonna be a hassle. I would rather do one more problem that is not quite appropriate for spherical coordinates, but I want to do it in spherical coordinates because it looks like the ones I gave you as a homework, and several people struggled with that, and I want to see how it's done since not everybody finished it. I will give it with generic numbers. You have a flat plane z equals a at some altitude a, and a cone exactly like the cone I gave you before. And of course, this is not, just like you asked, this is not very appropriate for spherical coordinates. It's appropriate for cylindrical, but they ask you to do it in both. Remember that problem, guys? So you have the volume of, or some function, something, and they say put it in both spherical coordinates and cylindrical coordinates. And let's assume that you don't know what function you are integrating. I'm working too much with volumes. Let's suppose that you're simply integrating a function f of x, y, z, dv, which is dx, dy, dz, over the body of the dead body of this is the flat cone, the flat ice cream cone. Then somebody licked your ice cream up to this point. And yeah, and you were left with the ice cream only under this, at the level of the rim of the waffle. Let's split this into two. They don't ask you to compute it. They ask you to set up cylindrical coordinates and set up in spherical coordinates. And thank you for the idea, that was very good. So let's see, how ugly is it? I think it's very easy in cylindrical coordinates. What do you do in cylindrical coordinates? You say, wait a minute. If z equals a has to be intersected with z squared equals x squared, I know the circle that I'm going to get is going to be a piece of cake. X squared plus y squared equals a squared. So really my cone, or cone, ice cream cone, has the radius a. Are you guys with me? Is it true? Is it true that the radius of this licked ice cream cone is a? It is true. Whatever that a was, yours was 43, 34, 37, God knows, whatever. Doesn't matter. I would foresee, I'm not a prophet or even a witch, I'm a witch, but anyway, I would not foresee somebody giving you a hard problem to solve like that computationally, but on the final they can make you set up the limits and leave it like that. So how do we do cylindrical? Is this hard? So R will be from 0 to a. Thank God that's easy. 0 to 2 pi is going to be for the theta. First I write dz. Then I do dr and d theta. Theta will be between 0 and 2 pi. R between 0 and a. Z, you guys have to tell me because it's between a bottom and a top. And I was about to take this to 3. So,
R.
R
A is what? Or R and A.
Yeah. It's A and R.
R is the one on the bottom, and A is the one on the top. And I think that's clear to everybody, right? Is there anything missing? Obviously. So what do I do when they ask me on the final, I say this is a mysterious function, what do you put in here? F of x, y, z? Yes, but yes and no, but because you say f of x of r z theta, y of r z theta, z of God knows z, z is the same. You understand? So you indicate to the poor people that I'm not gonna stay in x, y, z because I'm not stupid, okay? I'm gonna transform the whole thing so it's gonna be expressed in terms of these letters, r, theta, and z. Do you have to write all this? If you are a professional writing a math paper, yes, you have to. Or a math book or whatever, you have to. But you can also skip it and put F. I'm not gonna take any take-off points, I will understand. Times are very good. Never forget about your nice Jacobian. If you forget the R, this is no good, 0 points. Even with all the setup you try to do correctly. Okay, finally, let's see how you do this in spherical. It's not, yes sir.
When you're finding a volume, isn't it with a triple integral? Don't you just put a 1? When you're finding a volume.
No, I didn't say I just said, but you probably were thinking of math. I said I gave you too many volumes. I just said, and I'm tired of saying volume of this, volume of that. And in the actual problem, they may ask you to do triple integral of any function, differentiable function, or continuous function, over a volume, over a body.
All right.
So this could be, in the next chapter, we are going to see some applications. There are, and you maybe saw some in 12.6 like mass, momentum, those things. But in 3 coordinates, you have other functions that are density functions. You will have that included rho z, x, y, z, and so on. Okay, good. When you would integrate a density function in that case, you would have a mass. Because you integrate density over volume, you have a mass. Okay. In this case, we have to be smart. say f times r squared sine phi is the Jacobian. This is a function in r, phi, and theta, right guys? We don't care what it is. We are going to have the d something, d something, d something. The question is which ones, because that's not obvious at all, except for theta. Theta is nice. He's so nice, and we say, okay, theta, we are grateful to you. We put you at the end because it's a complete rotation, and we know you are between 0 and 2 to 5, very reliable guy. Phi is not so reliable. Phi, well, Phi is a nice guy, but he puts us to a little bit of work. Do we like to work? Well, not so much, but we'll try. So, bless you. So we need to know a little bit more about this triangle. We need to understand a little bit more about this triangle.
Well, the angle between, the angle at the bottom is 45 degrees.
Yeah.
How can you say?
Because the slope of that line is 1.
Right. So say, Magdalena, observe Z was A as well. Right? So that means it's a right isosceles triangle. If it's a right isosceles triangle, this is 45 degree angle. So this is from the phi from 0 to pi over 4. Excellent. Finally, the only one that gives us a little bit of a headache, but not too much of a headache, is the radius r. Shall I change the color? No, I'll leave it r. The r. So we have to think a little bit of the meaning of our rays. Drawing vertical strips or horizontal strips or whatever strips is not a good idea. When we are in spherical coordinates, why do we need to draw? Rays, like rays of sun coming from a source. The source is here at the origin in spherical coordinates. These are like rays of sun that are free to move, but they just bump against the plate, the flat roof. So they would reflect if this were a physical problem. Okay? So definitely all your rays start at 0. So you have to put 0 here, but this is a big question mark.
dr is
What's it's the
It'd be
angle.
a square root 2.
No, it's not a fixed answer. So you have Z will be A fixed. But who was Z in spherical coordinates? That's the only thing you can ask. So Z equals A is your condition, that is the roof.
That would be r times 2.
Very good. R cosine of phi of the latitude from the North Pole.
Yeah.
This is 45, but I mean phi could be for a point like this, phi will be this phi. You guys understand? Phi could be any point for the point inside P, phi will be the latitude from the North Pole. Okay, so the way you do it is R is between 0 and Z over cosine phi. And that's the hard thing. Since Z at the roof is A, you have to put here A over A is fixed, that 43 of yours, whatever it was, over cosine phi. So, when you guys integrate with respect to R, assume this F would be 1, just like you asked me, Alex. That would make my life easier and would be good. When I integrate with respect to R, would it be hard to solve the problem? Oh, not so hard. Why? R with respect, okay, integrate this with respect to R. We have R cubed, integrate R squared. We have R cubed over 3, right? Let's do this. Let's try to do this. Solve the same problem when F is 1. solve the same problem when f would be 1, or f equals 1. Then you get integral from 0 to 2 pi, integral from 0 to pi over 4, integral from 0 to a over cosine phi, 1 r squared sine phi, dr, d phi, d theta. The guy that sits on my nerves is again theta. He is very nice. He can be eliminated from the game. So I'll put 2 pi out. And I will focus my attention to the product of function. Well, okay, I have to integrate one at a time. So I integrate with respect to what?
It's equal to 2 pi x cubed.
So I get r cubed over 3. That, I'll write integral from 0 to pi over 4,
Answer is 2
r
pi.
cubed over 3. Between, it's a little bit of headache, r equals a over cosine phi, and I bet you my video doesn't see anything, so let me change the colors. R equals a over cosine phi, and r equals 0 down, that's the easy part. Inside here I had r cubed over 3, right? Alrighty, times sine phi, and all I'm left with is a phi integration, is an integration with respect to phi. Let's see, yes sir.
Take 1/3 out.
Well, I should be able to manage with this guy. A cubed divided cosine squared multiplied tangent 5. So the tangent 5 will be 1 over cosine squared. I'm writing just as you said, okay? Now, how much of a headache do you think this is?
It's not much of one. 'Cause
No.
That's the same as a tangent times a secant squared
Yeah.
with a constant pulled out.
So sine and cosine don't create the tangents. They'll give you 1, then 1 over cosine.
What's the simplest way to do it without thinking of tangent for tangent? Huh?
You can convert this to tangent.
Is there a u substitution there?
Yes.
What is the u substitution?
We can assume tangent here to be.
Is this good?
No.
No,
Yeah, it can
It
work.
could be like
Is it u cubed?
it's u to the minus 3. And that's okay.
Yeah.
So I have 2 pi
with secant.
a cubed over 3, out as constant because they are in my way, they are making my life miserable. Integral, and then I have u to the minus 3 times, for du I get a minus that is sort of, I have to invent a minus, and I have to invent a minus here in front as well. So they will compensate for one another. And I'll say du. But these limit points, of course I can do them by myself. But I need you, I don't need your help, but I pretend that I need your help. What will be u when phi is 0? 1. What will be u when phi is pi over 4? And from now on, we should do this. So I have minus 2 pi a cubed over 3 times, I integrate. So I add the power, I add the 1, and I add the 1. So you have u to the minus 2 over minus 2. Are you guys with me? Between u equals 1 and u equals root 2 over 2. If I promise you, if you have something like that in the final and you stop here, I'm not going to be blaming you. I'll say, very good, leave it there, I don't care. Right? Because from this point on, what follows is just routine algebra. So we have, oh, I hate this. not a calculator. But it's better for me to write 1 over root 2, like you said, because in that case the square will be 1 over 2. And when I invert 1 over 2, I get a 2. So I have 2 over minus 2.
Shouldn't a cube be divisible by 3?
Are you guys with me again? So I'm thinking the same. 1 over root 2. Square it. You have 1 over 2. Take it at the minus, you have exactly 2.
Yep.
And
So
you have
divided
2
by
over
2.
minus 2. Is this my minus? I'm so silly. Look at me. Minus 2.
It's a cubed over 3, not over 2.
It's going to be,
You've got an a cubed
9.
over 2 right there. And it was,
huh?
you just wrote 2 pi a cubed over 2. It's a cubed over 3.
It's just a
Yes,
3.
it's my silliness. I looked and I didn't. I saw this instead of that. Thank you so much, Alice. What do I have here? 1 over minus 2. In the end, what does this mean? Let's see. What does this mean? When I plug in, I subtract, I have, let's see, is what? This is minus 1 plus a half is minus a half. But that minus should not scare me, because of course a minus in a volume would be completely wrong. But I had the minus from before. So it's plus 2 pi times a cubed over 3 and times 1/2. So in the end, the answer, the total answer will be answered what? Pi a cubed over 3. Pi a cubed over 3. It looks very, huh?
That's a formula.
It looks pretty, actually, yes, it looks pretty because, now okay, I'm asking you a question. Could we have done that without calculus for, if somebody told you if it's 1 and say, yeah, that's a volume of some cone. What's the volume of a cone?
Pi r.
Area of the base times the height divided by 3. So you could have very nicely cheated on me on the exam by saying you have this cone that has pi squared times a, pi squared times a divided by 3 equals pi cubed over 3. When can you not cheat on this problem?
When you say you've got to do it with.
Exactly. When I say do it with the, well, I can say, okay. If we say set up the integral and write it down, you set up the integral, write it down. If we say set up the integral and compute it, you set up the integral, you fake the computation, and you come up with this. If we say set up the integral and show all your work, then you're in trouble. But I'm gonna try to advocate that for a simple problem that is actually elementary, one should not have to show all the work. Okay? All right. But keep in mind when you have 2 minuses like that, that reminds me. So there was a professor whose sink didn't work anymore. And he asked for a plumber to come to his house. He was a math professor. So the plumber comes to his house and fixes this and says, what else is wrong? Fixes the toilet, fixes everything in the house. And then he shows the professor the bill. So the bill said, oh my God, this is 1/3 of my monthly salary. So the plumber said, yeah, I mean, really? You're a smart guy, you're a professor, you make that little money. And yeah, really. So I'm so sorry for you. Why don't you apply to our company and become a plumber if you're interested, if you crave money? Oh, of course, I need money desperately. I have 5 children and a wife who stays home. Okay. He applies. And he says, pay attention, don't write that you are a professor or you have a PhD. Just say you just finished high school, or say, I didn't finish high school. So he writes, I didn't finish high school. I went to 10th grade. They accept him, they give him a job, and they say, this is your salary, but there is something new. Everybody has to finish high school. So they have to take AP Calculus. So he goes, oh my God, they all go, and there comes a TA from the community college. The class was full. he tries to solve a problem, trying to, with calculus, compute the area of inside this disk of radius 8. So the T8, okay, I did this, I got minus pi squared. And the professor says, okay, you cannot get that. Let me explain to you. Because I don't know where he made a mistake, because I still get where is minus pi squared? I don't see where the mistake is. And then the whole class, 12, 15, reverse the integral limits. Change the integral limits and you'll get a minus. So, you know, we cannot pretend that we want to do something else and we didn't finish high school and we'll get a lot more money. The person who came to fix my air conditioning said that he actually makes about $100 an hour. And I was thinking, wow, I'll never get there. So, but that's impressive. I mean, just changing some things and press the button, $100 an hour.
But it don't work full time the way how you think.
Yeah, and I think they are paid by the job. But in any case, whether it's a simple job and they just there is a contact that's missing or something trivial, they still charge a lot of money.
If a professor makes $400 an hour.
A professor?
Yeah, in Texas.
What? No.
Yeah, I know that professor. I don't tell you who.
Okay, I don't want to know. I don't want to know. But anyway, it's
But he doesn't do in the college. He did outside of college by just advising it.
Oh, you mean like consulting or tutoring or stuff like that?
Not tutoring, consulting for the big
Consulting.
firms.
Well, actually, I guess that if we did tutoring, which you don't have time for, we would make a lot of money. But the nature of my job, for example, is that I work about 60 hours a week, 60, 65, and I would not have any time left to do other things, like consulting, tutoring, and stuff like that.
You could be working in Disney.
I don't need money that much. I mean, I don't crave money that much.
No, you love to do that.
I have a friend who got a master's. She didn't get a PhD. She got an offer from Disney. I told you about her. She moved to California. She was a single mom. She earns a lot of money working for Pixar. And she helped with all that animation things. And it was about 15 years ago that she started. And it was really hot. We were all on Toy Story and that kind of, what was that called? There were two rendering algorithms. Two master students who were interested in that. They got in immediately. They were making, to be hired, I think a postdoc with a PhD was making about $40,000. That was my offer. My first offer was a postdoc at Urbana-Champaign for $38,000. While she was at $100 and something thousand to start with working at Disney. Imagine, with just a master's, no aspiration for a PhD or anything. So in a way, if you're thinking of doing this, like a master's in mathematics is probably paying off because it opens a lot of doors for you. And masters in general, I mean, masters in engineering opens a lot of doors. But in a way, you pay a price after if you want to study even further, get a PhD, stay in academia, then you pay a price. And if you want to augment your salary, you really have to be very good and accomplish some, get up in rank 2 or 3 times and get higher and publish and so on. But we all struggle with these issues, yeah. Yeah, it's a lot of work. But having a master's in math is not so hard. If you like math, it's easy to get it. It's a pleasure. It's not a lot of hours. I think in 36 hours in most schools you can get a master's. And it's doable. All right. let's go back to review chapter 11 briefly. Is this on the meter? No, but it's going to be on the final. Assume you have x equals u plus b, y equals u minus b. Right? The following derivative. dx over dt where u of t equals t squared and v equals t. Do this both directly. And by writing the chain rule for the mappings you have. Okay, how do we do this directly? It's probably the simplest way. Replace u by t squared, replace v by t and see what you have. So 1 directly. X of t equals t squared plus t, y of t equals t squared minus t. Good. So it's a piece of cake, dx over dt equals 2t plus 1, right? And unfortunately, this is just the first part of the problem. And it's actually asking us to show the chain rule for the mappings we have. And what mappings do we have? We have a map from t to u of t and v of t. And then again from u of t and v of t to x of t, y of t. And the transformation is what? X equals u plus b, y equals u minus b. And we have another transformation here. So how do you write dx dt? Well, x is a function of u and v, right? So first you say that should be dx dv round, which means you do it with the first variable. I'll write it for you to see better that initially your x and y were functions of u and v. Okay? Times, what is that? dv dt plus dx du. You can change the order. If you didn't like that I started with the v, I could have started with the u and a u and a v and a v here. Does it matter? Guys, do you mind really? VV, UU, shooting cowboys, doesn't matter. Remember just the procedure.
Isn't,
D, sorry, D. Because where there is no other variable, we would put D. So dx dt, let's see if we get the same answer. We should. What is dx dv? 1 from here. What is dv dt? dv dt?
oh, sorry.
1 plus dx du. 1 du dt. 2t. if we were to do it the same thing, so we got the same answer, right? We got the same answer. If you were to do the same thing quickly with respect to, say, dy dt, suppose that most finals ask you to do both. I've had students who didn't finish because they didn't have the time to finish. But that was just my policy when I graded. I gave them 100% no matter if they stopped here, because I said, you proved to me that you know the chain rule. Why would I punish you further? All right? So that's what I did. But I want you to do it now without my help. Both ways, dy dt. First you do it with the chain rule, okay? First you write explicitly these. So what do you have? dy, del y, del u, du dt, plus del y, del v, dv dt. I'm not going to write it down, you write it down. What I'm going to write down is what you tell me the numbers are.
Oh, for the y? 2t minus 1?
For everything. I mean, suppose that, yeah.
dy divided by du.
Or just give me the final answer in terms of Q. What are the two? The two things. Tell me. Tell me this times this plus this times that. No. What?
No.
So let's write it down. Let's write it down together. dy, du, dt plus dy, dv, dt. dv, dt. All right. One, right? This is 1. How much is dy dt? Du dt, I'm sorry. I said dy, du dt. Thank you. Plus minus 1, excellent, times 1. Of course, we would have done the same thing by plugging in directly and say, well, I have y, which is this is t squared, this is t, and I have t squared minus t prime is 2t minus 1. And that's a simpler way to verify whatever you do. Okie dokie. So I remember to do that, have this in mind, because on the final you may have something like that. As we keep going in the month of April, I'm going to do as much a review as possible for the final. Mark a star or F, not the grade F, but F round for the final. Put F and circle there. Say, review this for the final. And since we are still in chapter 11 review, put another problem on F, final review, that I didn't put on the midterm, but it may be on the final. Let's say given the constraint x squared plus y squared plus z squared equals 5, compute z sub x and z sub y. How do you do that? What is this called actually, and why is it so important for the final? It's called implicit differentiation. It appears on almost every final, at least once a year, so there is always a big possibility that you're going to see something like that. I taught you how to think in terms of implicit functions. You think of z as a function of x and y. That's a way of changing your perspective. So you say, okay, I understand that z must be viewed as a function of x and y. I'm just changing my perspective.
Well, sure, like that, why don't we just solve for z?
No. Solving for z would make your life a little bit harder. The whole idea in implicit functions is that you don't separate them. If you are going to separate them, you have to separately integrate these, and it's a headache. It's easier, actually, that's a good question. It's easier to do z sub x, z sub y without splitting into two cases. Okay? Step 2, differentiate this with respect to x. What do we have? 2x plus 0, thank God, plus chain rule, don't write chain rule, 2, jumpy down, that's the jumpy guy, power, jump down, 2z times, cover the 2 with your hand, you have to, z sub x, very good. Z prime with respect to x equals what? 0, good, thank God. So, z sub x, step 3, and the last step, z sub x will be what? Pull it out, pull this Mr. out. Minus x over minus z, over z. The other one?
It's symmetric, so.
It's symmetric, so Alex said, let's be smart and not do the whole thing over again. Look at this beautiful symmetric polynomial. You would have to be a little bit careful when one would have a 1 here and y would have a 2 here. It wouldn't be symmetric in x and y. But here, if you reverse the roles of x and y, it's not a big deal. Are you guys with me? You are with me. Z sub y equals minus y over z. Am I right? Okay, so keep this in mind for, I also saw when I was looking at Texas A&M library of finals. I'm a spy, I'm looking at all sorts of exams, and I was looking at University of Houston, I was looking at Texas A&M, University of Houston has a very beautiful online free library of Calculus 1 and Calculus 2 exams that I found very useful. Now, one of them, listen to me so you don't fall into this trap. On the Calc 3 exam, they wrote something like that, right? You don't have to write 1 over x squared and then compute that. You just say, okay, if the natural log of the argument is 5, then the argument is a constant, and I don't care what constant is, it's something that prime will give me 0, is the same problem. Are you guys with me? So in that case, I'm going to have just what kind of change? This will be to the 5, and that I still have 0, and it's the same answer. They just wanted to play games, and you can play very many nasty games. For example, you can make this. If you really have a dirty mind, and most mathematicians do, give this to your students. I mean, most people will freak out so bad when they see that they won't even touch it. It's just all in the head. Remember that log in base 17 of A would be what?
If it's, what would the constant to the 17?
Who knows?
What do you mean, the derivative of that?
No, expressed in terms of natural logs.
Natural log?
Natural log of A over natural log 17.
Very good. So what does this matter? In the end, you multiply it through, you do the derivative, you still get the same answer. Some people are trying to make things scarier than they are, just to impress. But when you think of the problem, it's a piece of cake. So don't be afraid of it. Oh, by the way, the final exam, so the midterm will be 10 problems plus 1 extra credit. And did I tell you how much time? It's going to be approximately, I say, actual time, needed time. For an average student would be about 40 minutes. Allowed time, 1 hour and 20 minutes. So you have from 12:30 until 1:50. Okay? On the final, just a guess, about 15, 16 problems, 2 hours and a half. 2 hours and a half. That's the, okay?
Is that allowed time or needed time?
That allowed time. If I manage to review very well with you all these concepts, guys, I guarantee you are not going to need more than 1.5. This is the allowed time. The allowed time for somebody who hasn't practiced enough. Okay? All right. I'm planning, now let me ask you what you think would be good. I have a bunch of finals. All the finals for Cal 3 look very similar in nature. The same kind of topics as the ones I reviewed, and I would like to know what you would prefer. I would have 2 or 3 all finals to give you. Would you prefer that you try them yourselves first and then I give you the solutions?
Yes.
Or I give you the solutions from the beginning? I'll give them the solutions anyway. But shall I?
Can they just be on a separate sheet where you could go through?
No, they are already on a separate sheet. For
Okay.
example, I have
Just give it to 'em.
fall 2013, whatever, or no, fall, whatever, spring 2012. They are from different semesters. They are all very similar. So I have 2 files. One of the exam itself, one of the solutions. I give you the exam, I'll let you work it for 2 weeks, and then I give you the solutions. How about that? But you work on it, you don't cheat on me and wait until you, because working things yourself, you're learning. If you expect other people to feed you the solutions, you're not learning as much. You are learning still, but you're not learning as much. Okay, it's getting ready. I have a few more things to tell you. Okay, I'm starting to remind chapter 13, necessary reminders. The gradient is very important. Gradient of the function f from R2 to R. We write that as z equals f of x and y usually. And what was the gradient? And this is good review for the midterm as well, but that's the beginning of section 13.1. So I'm actually doing 2 things. I'm giving you the beginning of section 13.1 while doing review for the midterm. You have gradient of f and xy. Some people ask me, do you prefer that I write on the exams, on the midterm, on the final, the angular bracket? Or you prefer that I write this in this form in the standard basis, IJ, standard canonical basis? It doesn't make a difference. In linear algebra, you would have to say what basis you are using. But in Calculus 3, we assume that you are using the basis which is 1001 in plane. Okay? So you have this basis in plane. I'm ambivalent. This is okay. You can use whatever you want. If you have a function of 3 variables, of course you have the gradient. That I prefer to write f sub xi plus f sub yj plus f sub z, big F sub zk. Okay? All right. Has anybody heard of divergence before? What is divergence? Gradient is something you've heard of before. But divergence, have you ever heard of divergence?
Movie?
The movie. Okay. Maybe in mechanical engineering. Have you heard of it before? No? Okay, suppose that you have a function, and that is a vector value function. What does it mean? A vector in itself, and will have coordinates, let's say xy, and let's assume that will be f1 of xy, no, this is not a vector, that's a scalar, times I plus f2 xy j. And one of you actually showed me a course in mechanics, and when you were using divergence in that, and I feel bad that I was not the first, maybe for some of you I'm not the first to tell you what divergence means. Divergence f, assuming that f would be C1, let's say, C1 function. What does this mean? It means that it's differentiable and its derivatives are continuous. We denote it as the div of f, but in engineering they denote it most of the time like that. This nabla symbols that you saw at the gradient with a little dot after that. Apply to it. If you don't put the dot, it doesn't make sense what I'm saying, okay? So pay attention and put the dot. All right, what does this mean? It means that you have the derivative of the first component with respect to x plus, it's going to be a real valued function, the derivative of the second component with respect to y. How do you generalize for higher powers? What if you have a function, assume you have a function f that looks like that, f1 of x1, x2, xn variables I plus the last one will be fn of x1, x2, xn variables times, we are in Rn, so this Eij doesn't make any sense. E1, E2, En would be the standard basis. Rn, what does it mean? It means the n equals of all the vectors x1, x2, xn for a computer scientist, an ordered set of n components, n values. N would be 7, 17, 29, I don't know, some natural number. So all these values are taken in R, where every R, xi is in R. What do you think the divergence of V will be in that case? Divergence of F. If you were to generalize what I said before. First component prime with respect to the first variable, all right, only, plus second component with respect to second variable, and so on, last component with respect to the last variable. So that would be the general definition. And now I'm asking you, assume exercise. Assume that somebody gives you a function f, x, y, on a domain in the plane, and f is C1, differentiable and with continuous variables. Actually, no, I want more. I want C2. So twice differentiable with continuous derivatives. Compute A, gradient of f. B, divergence of gradient of f, which you can also write divergence, like engineers do, of gradient of f. Do you know a name? That's the last thing we do today. A name for this, for operator, underlined here. So what would be a good name for this guy? I'm curious if any of you knows it from engineering, but we will see. So we are inserting one. Okay, A will be gradient of f. You say that's a piece of cake. She only wants the definition. Let me give her the definition: f sub xi plus f sub yj. And if we don't know what those are, this is derivative of f with respect to x at any point ti plus df dyj. Good. So we know what a gradient is. But what will this divergence of the gradient be? That sounds really weird. According to this definition, we have to see who big F1 and big F2 were. Who are big F1 and big F2? I'm going to take them in red. Big F1 and big F2. The components of the vector you apply divergence to. So by definition, what do I have to do? Somebody tell me, please.
F sub xx.
So yeah, I can write it f sub xx plus f sub yy, and that shows that you were fast, and I appreciate that. I can also write it like this, which is what I meant. This is what the book shows first, of course. It's the same thing. Now, I really doubt it that somebody knows but I wanted to give $1 to the person who would know the name of this. Let me see if I will stop it. So, maybe I have 75 cents in a candy. But does anybody know the name? Maybe I can help you a little bit. 75 cents, 85 cents, 95 cents. Do you know what this is? I'll give you a hint, because I know in mechanical engineering they already introduced this, and there are some physics classes, and we put a triangle in front, and we denote this triangle operator a certain way. And we can play a game. It's a letter that starts with for 95 cents. We have 10 more minutes.
Lagrange?
No, you are getting close though, because what kind of operator is this? You're getting close, 95 cents. Tomorrow, I don't need this. I hate, when I go to the airports, I don't like to have coins with me. What?
Lattice?
No?
Throw the word. Laplace, that's
95 cents. I wish I had the dollar. Yes, this is the famous Laplace operator. Laplace was a mathematician. Thank you. A French mathematician. And remember it. If you take the FQ, how many of you have to, all of you have to take differential equations, right? Okay, they will kill you with that. You're gonna see this all the time. This Laplace operator is really famous. I will tell you more when I come back. I'm gonna see you on Tuesday, right? Good luck on the midterm. For you, the people who feel overly prepared for the midterm, you can go ahead and read section 13.1 and see a little bit about Laplace operator. I'm sorry you didn't have a dollar. I only had 95 cents. But anyway.
thank you for
You're welcome.
Secretary, how many sections do you have left until we start?
Very few, 7.
7, are they all in chapter 15?
Yeah.
Starts at 5. It's like LA and G are.
So you knew about it from before. You've encountered this in an engineering course? Maybe in mechanics course?
I literally spent
Or physics?
physics over the Laplace, the law or something.
It's just naming all the mathematicians. That's what I said.